All right. It is 12 o'clock p.m. on the East Coast of the United States, 9 a.m. back at our headquarters on the West Coast. And thank you, everyone, for joining today. We're going to go ahead and get started. I've been looking forward to this one because what we're launching today is something we've been working toward for a long time. So, over the years, we've had a lot of conversations with customers across orchards, pack houses, quality teams. The feedback has been extremely consistent. The measurement itself is valuable, but the real bottleneck is everything around it. How do you scale measurements across hundreds or thousands of fruit? How do you keep data organized? How do you actually use that data to make decisions and not just collect it? And that's what really drove the development of Avo AI. This is not just a better model, although it is that. And it's not just a UI update. This is a shift from a measurement tool to a complete data system for avocado maturity. So today, I'm going to walk you through exactly what's changed and, more importantly, what that enables you to do that you couldn't do before. Now, before we get going, I want to just do some brief housekeeping. On the webinar today, we have Hunter Weber, our marketing coordinator. He's moderating the webinar. If anything at any point goes wrong from a technical perspective, if my audio cuts out, if the slideshow stops moving, progressing, or just goes away completely, please use the chat function in Zoom to let us know. If you have a question that pertains to the content of the webinar, then please use the Q&A function, because at the end of this webinar, we'll do a Q&A session and I will be pulling questions directly from that Q&A function and not from the chat. So I won't be seeing any questions that get posted in the chat, just ones that are in the Q&A function. So please use that. And if you want to speak to your other fellow guests, you can use the chat. Hunter will also be posting relevant links in that chat. So in the chat, you might want to just have that up and monitoring that for links to our website where we have various resources regarding the Avo AI. So now that that's out of the way, I just want to quickly go into a brief introduction of our company. So at Felix Instruments, we've been working in fresh produce for over 15 years. We're focused mostly on fruit quality measurement and real-time gas analysis. One thing that's really important about us that we really value is everything is done in-house at our headquarters in Camas, Washington. So the engineering, the design, the manufacturing, the assembly, all of that happens in our facility. And all of our systems are deployed globally across orchards, pack houses, ripening rooms, and retail environments. Now, for me, for anyone that is not familiar and you haven't seen me before, my name is Galen George. I lead the applied science team here at Felix Instruments. My background is in biochemistry and food science, and for the past 7 years, I've been focused specifically on fruit quality measurement and modeling. So I sit right at the intersection of the science behind the measurement, the modeling behind the predictions, and the real world constraints of actually using these tools, which is exactly where Avo AI was built. So here's how we'll walk through this. First, we'll talk about what Avo AI actually is at a high level. Then we'll get into what's changed from the previous application. And this is where things really start to diverge. From there, we'll talk about improvements in modeling and accuracy. And then we'll spend time on workflows, because this is a major shift in how the device operates. After that, I'll show you how simple it is to update your device, and then we'll wrap up with questions and answers. So let's really define what Avo AI is, because it's doing several things at once. First off, this is a next generation application. And what I mean by that is we've moved beyond just taking a measurement and displaying a number. Now, every measurement is part of a structured data set that is tailored to your organization's operations, something you can actually analyze, compare, and act on. Secondly, we're combining spectroscopy now with machine learning. So we're still using that same hardware platform, the same NIR interactance optical geometry. That hasn't changed. What has changed is how we interpret that signal. So instead of traditional chemometric models, we're now using deep neural networks to translate spectra into dry matter predictions. Third is the improved accuracy and consistency. Of course, one of the main drivers of this update was to improve prediction accuracy, especially at the low and high ends of the maturity range where our previous models experienced higher bias in predictions. With the use of machine learning and deep neural networks, we were able to significantly improve the performance of the model in the 14 to 20 and 32 to 40% dry matter ranges. But I also want to emphasize consistency here because in practice, variability doesn't just come from the model, it comes from different users, different fruit, and different environments. So Avo AI is designed to reduce variability across the entire system. And fourth, this platform is built for real world workflows, not just lab workflows, not just ideal conditions, actual field sampling, actual intake QA. And that's really the unifying idea behind Avo AI. It's built around how the work actually gets done. Now, with that foundation, the natural next question is what specifically changed? There are four major changes. Each one addresses a different limitation of the previous system. First is the modeling approach. As I mentioned, we've moved from traditional chemometrics to deep neural networks, to AI, which allows us to capture much more complex spectral relationships. The second is the prediction performance. You're getting better accuracy across the full dry matter range, especially at those extremes. The third is in the data structure. So instead of being limited to a single organization scheme, you have the ability to customize your data structure. And fourth is the user experience. The interface has been redesigned around guided workflows, which reduces user error and makes the system generally easier to use consistently. So this isn't a single improvement, it's a system level upgrade. To understand why that modeling change matters, let's take a closer look at how Avo AI is actually using machine learning. So how does the machine learning actually work in practice? At a high level, we're training models on very large data sets of avocado spectra paired with lab measured dry matter values. But the important part is what the model is actually learning. It's learning the relationship between spectral signals and fruit composition. And because we are using a deep neural network, we can capture complex patterns that are very difficult or even impossible to represent with traditional approaches. And that's the key difference. Once that model is trained, it's then deployed directly onto the device. So every time you take a measurement, that prediction is happening instantly on the device in real time. There's no delay, there's no cloud or Wi Fi connection dependency. And that's what enables consistency. You're applying the same model, the same logic across every measurement, regardless of where or how it's taken. And this is where you start to actually see the impact of that change. This is where all that work shows up in a way that actually matters. Historically, the biggest issue has always been the edges of the range. Low dry matter gets overpredicted, high dry matter gets underpredicted. And those are exactly the regions where decisions tend to matter most. What Avo AI does is reduce that bias on both ends. If you look at the plots here on the left, you can see that there's tighter agreement with the ideal one-to-one line. And on the right, this is a plot of the residuals. And the residuals are more centered and evenly distributed than our previous model. So this isn't just improving average performance, it's improving performance where traditional models break down. And that directly translates to confidence because now when you see a low value or a high value, you can trust it. Now, these graphs are pulled straight from our validation report. Our full validation report will be available for you to download from our website. We'll have links to that at the end of this presentation. So once you've improved that confidence, that's where the operational impact comes in. So this translates into 4 real world benefits. First off is better harvest timing. You're making decisions based on more reliable maturity data. Second is reduced quality risk. You're minimizing immature or overmature fruit entering the supply chain. Third is more consistent eating quality. So you'll have better uniformity in ripening and in texture, better storage quality throughout that storage lifetime. And fourth, you'll have more confident decision making across your entire operation. So this is where modeling improvements actually become business outcomes. Now, everything we've talked about so far is about measurement and prediction, but this next section is where Avo AI really changes how the system is used. So there's a lot of information on this slide, but we're going to just talk through it and hopefully give you a better understanding of how things are now structured. This is probably the biggest shift in the entire system. So Avo AI introduces workflow-based data organization. This is fundamentally different from how the system worked before. Instead of collecting measurements into a flat list, you're now collecting structured data sets aligned to your workflow. So there are 3 modes that we've created. We have in-field mode, post-harvest mode, and data collection mode. Each one is designed around a specific use case. And each one uses a hierarchy that matches how data is actually collected in that environment. The key point here, though, is flexibility. These hierarchies are defined by simple text files on the SD card. What that means is you can align the system with your existing naming conventions, your existing processes, without having to change how you operate. So instead of forcing structure onto your workflow, Avo AI adapts to your workflow. You can see here under each of these different workflow modes, we have a specific use case lined out, obviously with in-field where the intention was to tailor it towards people that are in the orchard, doing sampling out in the orchard pre-harvest. In the post-harvest mode, we were intending that to be for the people in the pack house or doing intake QA, inbound lot inspection, whether at any point really in the supply chain. And then this data collection mode is kind of our open-ended mode. It's really mostly developed for researchers or when we're doing data set development to create new calibrations to collect data for, improving upon our model performance. And each one has a specific hierarchy that is followed. So in the infield mode, we start at the orchard level, and then we define a cultivar within that orchard, and then we define a plot within that cultivar. In the post-harvest mode, this is what is most similar to the current application. We have the bin level, which obviously you can rename to say whatever you want to say. And then we have the fruit level underneath that. For the data collection mode, it goes one step further into going all the way into taking multiple measurements of a single side of a fruit. So that's when we need to collect, really robust data about individual fruit, which isn't necessary for the other applications. So let's kind of deep dive into each of these. I'm going to give you a high-level overview of each of these modes, but we do have on our website, and there'll be a link to it at the end, a full video of a user interface walkthrough so you can actually see for yourself what each of these modes look like, when measurements are taken, how everything's organized in the actual user interface of the device. So Obviously, you can view that after this is over. For the infield mode, obviously, what I mentioned before, it's intended for orchard sampling. You're organizing measurements by orchard location, cultivar, plot, or block. And this allows you to compare dry matter across different areas and identify variability. You can generate on device summary statistics at the individual plot level, or at the cultivar level, or at the higher level, the orchard level. And ultimately, this supports better harvest timing decisions based on structured field data. Post harvest mode shifts to the pack house. Here, everything is organized by bin. You can measure individual fruit within each bin and understand within lot variability. You'll get the real time summary statistics during the intake. And this supports decisions around lot segregation, quality control, storage, and it's all based on this structured bin level data. And data collection mode, as I mentioned, is really just for researchers doing data set development for custom calibrations. And in this mode, you're organizing by batch and fruit and an individual fruit measurement side. So the side of the fruit if you're doing multiple measurements per fruit. Um, And then what this allows is improved accuracy and repeatability for an individual fruit when that really really matters. And it allows you to build clean, structured data sets to use for validation or model development, as I mentioned. So now you've collected structured data. The next question is how you access and use it. All the data is still stored locally on the SD card, just like it has been in previous app iterations. So you'll always still have that direct access to your data. But because it's already organized, you're not starting from scratch every time you export it or having to do extensive post processing or renaming to align it with your internal systems. And if you enable connectivity, that data can be pushed seamlessly to a data server or to fruit maps. And so now you're moving from a measurement to a data set to a visualization to a decision. We have, with this Avo AI interface, we have made it a lot easier for integration into QMS systems. So if you do have a existing QMS system, a quality management system, or some other kind of system where you want data to seamlessly be transmitted or integrated into, that's much simpler of a task now than it was previously. And so if that is something that you want to do, all you have to do is reach out to us and let us know that that's something you want to do, and we can easily help you with that integration. And really, that's the full pipeline that Avo AI is enabling. Is this take a measurement on the device, the model runs on locally on the device. From there, you gather up a whole data set, you get insights directly on the device, and those insights on either on a plot level or a bin level or a orchard level. And from there, you can then send them to fruit maps for visualization if you're an infield, orchard management kind of system application, or you can send them easily to, any other visualization tool to get those insights. And from there, it's a lot easier to just make a decision based on that data. Now, some of you might be wondering, how do you actually get this on your device? We've made this intentionally simple. So there are no firmware updates or hardware changes needed to upgrade your device if you already own one to the F751 Avo AI application. And everything involving the update happens through the SD card. So really all it takes is backing up your existing SD card, copying over the new files that you can download from our website, and then insert that SD card back into your device and power it on. That's it. So upgrading is fast, it's low risk, and it's easy to deploy across any existing devices, even if you have multiple of them. As I mentioned, we all will have all the resources that you need, instructions, the download itself, the user interface walkthroughs, the user manual. Those are all up on our website, and you can easily access those to help you get through this updating process. But again, we've made it very intentionally as simple as possible. So just to wrap everything together, Avo AI is a next generation application that we have built on machine learning or AI based chemometrics. It introduces this new workflow based data structure that is aligned to your real world use. Your data is now organized and ready for analysis right on the device. You get more reliable predictions across all your maturity stages. So that means less offset calibrations throughout the season. And upgrading is super simple. So this is really about moving from measurement to a fully usable data system. So thanks for taking the time to join this. This has just been a pretty brief overview of all the features of the new Avo AI. If you have questions, obviously, please use that Q&A function, and I will open that here in a second. But just wanted to make you aware that you can scan this QR code here, and it'll take you to the download for the actual application files, the instructions to how to update, the user manual, the UI walkthrough video, and our full validation report. So we're always happy to, follow up directly as well if you are having issues with updating, or if you're just curious more about updating. You can always, send us an email. You can give us a call. We also, if you don't currently own a device and are interested in owning one, you can always book a consultation with me. You can reach out to our sales team and book a quote. You can also just fill out the form directly on our website to ask for pricing, and we're happy to follow up on that. So, without any further ado, what I will do is open up this Q&A function, and we will start talking about the Avo AI and what you guys are curious about it. So the first question is, does the Avo AI machine learning come on the F750 in the same way that we've presented it for the F751? Yes. The answer to that question is yes. You can use it on the F750 as well. The caveat to this being that it you are not able to have multiple apps on the device along with the Avo AI app. So traditionally, for anyone that's unfamiliar, the F750 is our research grade unit, and typically people might have more than one commodity type app. So they might have avocado and mango, or mango and kiwi fruit, or avocado and kiwi fruit, or grape. But in this case, if you want to use the Avo AI and you have a 750, you can do that, but then you're not going to be able to have the other commodity apps on your device at that same time. The easy workaround to that is just to have a second SD card. Just buy a new SD card, put the Avo AI app on that SD card, and when you're ready to use it, you can just swap out your SD cards. So thank you for that question. The next question is this is a good one. Can you show a sample of the data set that one can collect? So I don't have one currently up in front of me, but we have examples of all the data sets in the user manual. So if you go to the user manual, um, there's a section of that user manual where we actually have screenshots of what each of the data sets look like. It's basically a text file. It's a running log that has all of the metadata. And it's going to have your date and timestamp. It's going to have a unique ID for that measurement, which allows us, it's especially helpful with troubleshooting, but also allows you to make sure that there's no duplicate measurements or things like that. And then it'll have all of the information regarding your organization hierarchy. So it'll say, orchard. If you're doing the infield app, it'll say orchard, and then it'll say whatever cultivar of that fruit, and then it'll say the plot, the name of the plot, or the name of the block that you were measuring that from. And then it'll have the GPS coordinates, the latitude and longitude, and then your dry matter prediction. So every line will be its own sample, right? Its own measurement. And within that, you'll have all of that metadata ready to go. And it's really simple to just copy and paste it into Excel. It automatically parses itself into the right into individual columns so that you can just do any kind of post processing if you need to or visualization of that data. The next question is a good one is does the Avo AI help the customer to calibrate their avocado variety that might be different than Haas? So obviously, not everyone is just working with Haas avocados. And yes, the Avo AI app is going to perform slightly better with varieties that are non Haas, but there is still a limitation when it comes to the tropical or the smooth green skin varieties, where that is a limitation of what data is in the model. So we've had good luck with Shepherd and Maluma Hass, um, and slightly more limited success with Lamb Hass. Um, but for things for varieties like Fuerte or Pinkerton or those kind of varieties, we still we don't have a lot of that data in our model. So what the customer can do in that case is collect some data from those varieties, and we can easily integrate that into the model and give them a new model that specifically for them that incorporates that data. So it will improve performance slightly. I wouldn't say that it's going to completely fix. It doesn't magically now work on all avocado varieties, um, because we haven't updated we haven't included significantly more data from those varieties in this upgrade. The next question is, can we get this presentation? And yes, obviously, I forgot to mention that this presentation will get sent out to everyone that has signed up for the webinar. So you'll get a PDF of the slides emailed to you within the next 24 hours. The next question, here's a good question. Can it only be used for avocado or can it be used in measuring other fruit quality? It's a great question. We do have models for other fruit varieties. So we have a mango model, we have a mango app, we have a kiwi fruit app, we have a table grape app, and we have a bunch of other apps that work fairly well for things like berries and melon and things like that, apples and pears, cherries. And so it can be used for a very, very wide variety, almost, every fruit you could possibly think of. There are some limitations there, but um, the model itself, the Avo AI model, is only intended to be used for avocado. It will not predict things for other fruit varieties if you use this specific model. But if you're interested in other commodities, what I would recommend is you reach out to us and we can set up a time to meet and I can talk to you about what our other offerings are for our other commodities. The next question, how much percentage of segregation transportation damage can be prevented by using this machine? Um, that's a fairly complex question that I don't know if I can give you an exact number on. But what this will do is allow you to more confidently segregate your lots into dry matter percentage categories and allow you to then make better decisions about, how long these could be stored, how well they'll store, and what conditions to store them in to prevent that kind of damage or spoilage. So, um, you know, you could easily see, with the confidence that you get from this app, you could easily see someone who is doing no testing, having a 100%, increase in prevention, right? But someone who's already doing some limited testing, when they are able to collect more data, get even better insights, then, that can be, still a significant improvement, probably, 50% improvement, right? But to be able to just give you a complete answer off the top of my head, I don't think that's possible. Um, The next question is what about time consumption doing this test in a really big orchard, right? So every scan, one thing that has improved slightly as well with the device is that our scan time has decreased. So it is a shorter scan. than with the previous app. And so a single fruit, a scan will take about 10 seconds. And so you can consider that if traditionally we're doing traditional testing, let's say you're taking 10 avocados, let's just say 5 avocados per block. Um, then what you're going to do is you're going to then run them to the lab. You're going to cut them. And if you're using the microwave, you might get results in 30 minutes or so. If you're using the oven, you're not going to get results for 2 days. This will give you an answer in 10 seconds. And it then it enables you to collect significantly more data. So that is kind of the value of this technology is it allows you to take a bigger data approach, get more representative data. So you can then understand the variability within your orchard. Um, so you can put in as much time as you want. If you want to use it as a direct one-to-one replacement, that's not really, the best use of the device, I would say. But if you wanted to do that, then you're going to decrease your testing time by hours or days. If you are, using it in a more, I guess, big data approach, then, you could spend as much time as you want out in the orchard scanning. But coming up with a representative sampling plan is going to be the best way to go about it. So you could, say, traditionally we only tested 5 per block, but let's try to go and get 1 per tree or 1 every other tree, or 3 per tree. And then you can go from there and refine it and say, okay, well, if we do 3 per tree, then, it's taking us, approximately, 4 hours to get through this block. And we have 20 other blocks to do. So you might need one, more devices, or two, you might need to pare down that sampling. But in general, you're going to see a significant decrease in time spent doing testing. The next question is, can the instrument be used to measure external qualities like the skin toughness or strength? So this is a great question. Um, Firmness, what you would think of as firmness, right, is a physical parameter. What optical spectroscopy is doing is measuring vibrations of chemical bonds. Now, there might be some secondary correlation between the amount of water or other compounds within that fruit and the firmness of the fruit. But that is a tenuous connection to make. It's not a direct measurement. So, in general, spectroscopy is not a tool that is traditionally used to measure physical parameters like skin toughness, or firmness. And so, there is a potential to use it as a rough estimation. There are some people that have built models to do that, but I wouldn't say that you can just fully replace a penetrometer test or durometer test with a spectroscopy based solution like this. And our model does not include firmness as a measurement. So we simply stick to dry matter, which is a direct measurement of the water content. The next question is, will the device be able to accurately capture the dry matter of avocado from different origins? For example, its calibration is built on a specific origin, but we are working in a different region. Yeah, so that's one of the advantages of using AI, is that it can learn these complex relationships. Right, we're trying to reduce that variability. Regionality and seasonality are two really big drivers of variability in a data set. So when we build our data sets first, we include avocados from as many regions as we possibly can. Um, Now, the beauty of AI is that it learns even when you only have a little bit of data. And so even if it's not, a massive amount. So this Avo AI upgrade will definitely perform much better with avocados from different origins than our previous model did, where previously we recommended having specific calibrations for every single region of origin or country of origin. Now, you're going to be able to get away with just using the one app, and the one offset, for that. The next question, another great one, is does Avo AI perform just as well with different sizes of avocados? So there is a limitation here. The the light from the instrument will penetrate into the mesocarp, right? Penetrates through the skin, the exocarp, into the eating flesh or the mesocarp of the fruit. And that light, if that layer of mesocarp at the equator of the fruit happens to be super thin, and then the seed itself is large, or just that layer of flesh is thin, there's a chance that light is going to hit the seed, and that is going to cause weird, erroneous predictions. So typically, we recommend, I'm going to get the number wrong. I want to say caliber, the size 48 avocados or larger is typically what we recommend that it or is used. If you use it in the way that we, typically use it where we're scanning at the equator. Um, I have spoken to various researchers who have used it on smaller caliber avocados, but instead of scanning at the equator, they scan at the neck of the avocado to remove the potential for seed interference. So if that is the case, if you have very small avocados, that's something I would recommend trying is scanning at the neck instead of at the equator of the fruit, just to avoid the possibility of that seed interfering with the measurement. The next answer is, can the device be used to measure the ripeness as well? Um, so what the device does is it measures dry matter content, and dry matter content does change a little bit during ripening, but it's mostly just due to water loss. And so typically with ripeness, you're just kind of looking at firmness and color change. And so this device will give you dry matter content, but if you're looking at determining if your avocados are ripe enough for market, then this isn't going to give you that exact insight. It will just tell you what dry matter level your avocados are at in order to allow you to make good decisions about, is this going to be good eating quality, right? So dry matter is directly related to oil content or directly correlated to oil content, which is the number one parameter for consumer acceptance for eating quality. So it will tell you like this avocado is, at a quality that is high enough dry matter that it's going to be accepted by consumers, or this is too low dry matter, it's not going to be high eating quality. Another caveat for this device, and this is an important caveat, also stated in the user manual, is that when avocados are fully ripe and they're no longer firm, our model does not perform well, because what happens is you start to get air gaps, you start to get breakdown of cellular structures within that mesocarp, and that throws off the scattering of the light and throws off the model completely. So device is intended to be used on firm avocados only, not ones that are pulled off the supermarket shelf or about to be delivered to the supermarket already, soft. So that being said, you can tell what the dry matter is. You can tell how well it's going to be accepted at that market. But if you're trying to use it on soft fruit, it's not going to do anything for you. And here's another good question. If we use it on the field and the fruit temperature is higher than normal, are there differences in measurements when the fruit temperature is different? That's a great question. So NIR spectroscopy is sensitive to temperature. So the temperature of the target is going to alter the spectra. However, what we've done and what the AI has enabled us to do as well, just like with the regions of origin, is a lot of our data set, is built on fruit at varying temperature ranges. And so what that does is it kind of builds in an automatic temperature compensation. Now, that really only applies within a certain limit. So if you have a 40 C day out in the field, then you're likely going to see slightly altered, biased predictions. Um, in that case, there's a couple things you can do. If you are going to consistently be measuring in an environment where the temperature is always above 30°C or 35°C or something like that. Then what you could do is calibrate the device with fruit at that temperature and set your bias, because how temperature presents itself in as error within the model predictions is a bias. So that means that all the predictions are going to be too high or they're going to be too low. So what I would recommend is either calibrate if you're at those really extreme temperatures, then I would recommend calibrating at the temperature that you are most commonly going to be taking measurements at. The same applies in the reverse. If you're working in cold storage and you want to measure fruit that's always at 2 degrees C or something like that, then calibrate your device on 2 degrees C fruit. Our device will compensate temperature, between 10 and 30 C. Um, but if you start to get below that or above that, then you're going to see a bias. And so you should calibrate your device, do the offset calibration according to the temperature of the fruit that using the fruit that's at the temperature that you are going to see most commonly in your operation. All right. That looks like all the questions. If you do think of another question later on, feel free to send us an email or give us a call. We're happy to help. Like I said, all of the resources that you need, the Avo AI user manual, the actual download for the app files, the update instructions, the UI walkthrough video, the validation report, and this slideshow deck from this webinar will all be made available to you. You can actually find all those resources now on our website. If you go there, you can just scan this QR code. If you are interested in receiving pricing because you don't have a device yet, feel free to just send us an email or you can fill out the form on our website and we're happy to help. So thank you all again for joining us. And we look forward to seeing you all using this new release that we've just put out. So have a good one, everyone. Bye.